Now let us try to solve this problem here. What do we have here is now that this is second order differential equation and it is non-homogeneous. Now on the right hand side you see that is x sin 3x plus cos x. Now let us try to solve this. Now the auxiliary equation corresponding to this would be, let us write down the auxiliary equation corresponding to this. Okay, so we have that is m square minus 1 is equal to 0. So you got the roots as plus or minus 1. So these are the roots here. Now the complementary function corresponding to this is yc, which is c1 e to the power of minus x plus c2 e to the power of x. Okay, now let us find the particular integral for this. Now that is x sin 3x divides by d square minus 1, and this is cos x divided by d square minus 1. So let me call this as particular integral 1, that is p1, and let me call this as particular integral p2. Okay. Now suppose now we have this to find two particular integrals here. Let me first find the first particular integral p1. So that is x sin 3x divided by d square minus 1. Fine. Now let me put this as x into imaginary part, that is e to the power of I 3x here. Okay, sin 3x I have written as e to the power of 3i x or I 3x divided by d square minus 1. Okay, now let us substitute d as d plus 3i. Let me substitute that here. Okay, so that is integral part of e to the power of I 3x, right, and that is, if I substitute it, x divided by, this is d plus 3i whole square minus 1 plus the brackets. Let us try to simplify this further. Now when you expand this d plus 3i whole square, okay, which we have in the denominator, this one, when I try to simplify this on the whole, so the integral part of e to the power of I 3x, okay, and x divided by, and I'll simplify this, so d square plus 6id minus 10, so close the brackets. Now let us remove minus 10 from the denominator, so I get the integral part e to the power of I 3x. So this is I'll take minus 1 by 10 outside, and if I bring it on to the numerator, so I get 1 minus, now this is d square plus 6id divided by 10, close the brackets, and this is to the power of minus 1, okay, into x. I multiply this. Now when I expand this, that is integral part of e to the power of I 3x, and this is minus 1 by 10, and if I expand this, so I get as 1, this is plus, this is d square plus 6id divided by 10. Now I won't be requiring the other terms here because this goes to 0. Now close the brackets. So let us compute this further. Now if I multiply with this, and if I take twice derivative of x, so that goes to 0. So finally I will be getting the integral part of e to the power of I 3x, okay. So this is minus 1 by 10, okay. Now this x with the first term, if I multiply this, plus, now if I try to simplify this further, I get 3i by 5, okay, close the brackets. Now e to the power of I 3x can be written as cos 3x plus I sin 3x. So that's what I'll be writing that. So that is, I have minus 1 by 10. Now the integral part of that is cos 3x plus I sin 3x, right, that is multiplied with x plus 3i by 5. Fine. Now let us compute this further. If I multiply that, so I need to get the integral part of this, so that is 1 minus 1 by 10, so that would be 3 by 5, and cos 3x plus x sin 3x. So I get this. Now this is the first particular integral, that is p1, which we have done it. So we have done this. Okay, now let us try to calculate this p2. So the p2, which is cos x divided by d square minus 1. Now if I substitute d square as minus 1 square, so that would be minus 1 by 2, and this is cos x. So we got p1 and p2, p1 being this and p2 being this. So I got yp as p1 plus p2. Now y is equal to yc plus yp. So what we have already calculated what is yc being this, so, and yp being these two, right? So I have put this. Let us move on to the next problem here. Again the same thing. This is second order differential equation, and again the previous one which we got the roots as +1 and -1. So here also we get the same thing, since it is a second order differential equation, and and it is a non-homogeneous equation. So we got this as plus or minus 1. So complementary function yc is c1 e to the power minus x plus c2 e to the power of x. Now let us find what is yp here. So yp being, it is 1 plus x square multiplied by e to the power of x divided by, this is d square minus 1. Again we have the two particular integrals here, x sine x divided by, this is d square minus 1. Fine. Now let us consider this as P1 and this as P2. Now let us find what is P1 here. So that is 1 plus x square into e to the power of x, okay, divided by, this is d square minus 1. Fine. Now let us substitute d as d plus 1 here. Okay, so that would be, now that is P1, which is e to the power of x if I take it outside. So this is 1 plus x square divided by d plus 1 whole square plus 1, sorry, minus 1, right, minus 1. Now when we expand d plus 1 whole square, and if I try to simplify that, so I arrive into this, that is, and the denominator will be having as, this would be d square plus 2d. Now that is multiplied by 1 plus x square here, close the brackets. Now if I remove 1 d outside and 2 also outside, so I'll be having e to the power of x divided by 2, and it is multiplied by 1 by d, and in the denominator will be having as, this is 1 plus d by 2, fine, and it is multiplied by 1 plus x squared, right. Oh. Now let us bring it on this on the numerator. So e to the power of x divided by 2 and multiplied by 1 by d. So I get 1 plus d by 2 to the power of minus 1, and it is multiplied by 1 plus x square. Close the brackets. Now let us try to expand this here. Now this is P2. Now 1 by 2 e to the power of x. Now this is multiplied, again this is 1 by d, and this is 1 minus d square by 2, sorry, I mean not d square, it is d by 2, that d by 2 here, plus we have d square by 4 and so on. Close the brackets. Now this is multiplied by 1 plus x square here, and what do we get? So let us multiply this. So I have 1 by d, right, and if I multiply the first term, so this is 1 plus x square, and this is minus 1 by 2, and it is multiplied with differentiation of the first one, it goes to 0 and 2x, right. Now again multiplied with 1 by 4, and first time if you differentiate that, so I get that as only 2 will be left here, so close the brackets, right. Now further if I try to simplify this, so 1 by 2 e to the power of x, close the brackets, 1 by d, and this is, now this would be 1 plus x square and minus x, and this is 1 by 2. Now this closes brackets. Now we know that 1 by d is integral dx. So let us integrate this here. So I get 1 by 2 e to the power of x. Now this would be, now the integration of that, the whole thing, which would be, now this would be x square, x cube divided by 3 minus x square by 2 and plus 3x divided by 2, so close the brackets. Now further if I try to simplify it, so I get 1 by 2 e to the power of x, close the brackets, and I get 2x, now if I factorize it, so I get 1 by 12, and this is 2x cube minus 3x square plus 9x, close this bracket. Now the first one we have already done it, which we got this as this being the entire thing is P1, right? We have got this. Okay. Now let us find what is P2 here. So that is x sine x divided by, this is d square minus 1. Okay. Now again we have the integral part of x into e to the power of ix here. This divides by d square minus 1. Now let us substitute d as d plus I. Okay. Now that is, you have integral part of e to the power of ix. Okay, so it is multiplied by x. Now this is divided by d plus I whole square minus 1. Close this. Now let us simplify this. Now I get this as integral part of e to the power of ix, and in the denominator I'll be having, after simplifying, I get that as d square plus 2id minus 2. So close the brackets. So what we have done is we have tried to simplify this further. Now let me take minus 2 outside and get the things done clearly. Okay, now if I take 1 by 2 outside and have e to the power of ix outside, right? So this is multiplied, and if I take to the numerator, so this is 1 minus this whole thing, that is d square plus 2id divided by 2, and this is whole inverse, and it is multiplied by x, close the brackets. Now further simplification for this. Now the integral part of e to the power of ix, okay, now this is x divided by now if I already have brought it down, right? Okay, let us expand this. So I get that as minus 1 by 2, and this is 1 plus, now this is d square plus 2id divided by 2, and so on. So I won't be requiring any other terms at all, because that goes to 0. So the integral part of e to the power of ix, so that is, if I multiply that, 1 by 2, and this is x plus 1 by 2, the first term becomes 0 plus 2I into 1, so close the brackets, so close this. So further, if I try to simplify this, the integral part of e to the power of ix, okay, so this is minus 1 by 2, and this is x plus I, close the brackets. Now e to the power of ix I can write as cos x plus I sin x, so minus 1 by 2. This is integral part of, that is, you have cos x plus I sin x, and it is multiplied by x plus I. So let us try to solve this. Now when I take that 1 by 2 and integral part of, now if I multiply that, so I get x cos x plus I x sin x, right, plus I cos x minus sin x, close the brackets. Now the only one I will be requiring is the integral part here, so that is x sin x here, and I have cos x, so that is minus half of x sin x plus cos x, right? So what we found is P1 and P2. So yp is equal to P1 plus P2. So P2 being this and P1 being this. So y is equal to, so y is equal to yc plus yp. So yp we have already done it, so yc being this. Now what you are looking at is a subscription. Yeah, you can subscribe. Thank you for listening. I'll be back with some more videos.